Hello everyone, welcome to the Quantity Surveying Fundamentals. My name is Onalinna Marumo. To everyone who's just recently subscribed to the channel, a warm welcome to you, and to the returning subscribers and viewers, thank you so much for tuning in. We are still on the subject of excavations, and in today's exercise we are going to take off quantities for bulk excavations on a sloping site using Simpson's rule. So that is the formula that we are going to use to calculate the volume of our excavation. To use the formula, there must be an odd number of cross sections or ordinates, which means an even number of spaces between them. Secondly, the distance between each consecutive cross section must be the same. So that's 10 meters or every 5 meters. A1 is the area of the first section, and it is taken once. AN is the area of the last section, and it is also taken once. AE refers to even numbered intermediate areas, and these are multiplied by 4. AO refers to odd numbered intermediate areas, and these are multiplied by 2. This is our site. It measures 120 meters by 80 meters. So we have a cut section and a fill section. Something important to note, both the cut and fill are sloped at an angle of repose of 45 degrees. What this means is that the sides of our excavation and fill areas are not vertical, right? But instead are sloped to ensure that our excavations are self-supporting. To keep this video short, we will tackle only the main excavation, and then in the videos to follow, we will address the quantities of materials that need to be excavated to form that angle of repose, and also the fill section. Okay, so our description reads, open face excavation in earth to reduce levels over sloping site. The unit of measurement is cubic meters as indicated. So that means in our dimension column, we are going to have 3 dimensions. We're going to start off by working out the average depths at all the sections, that is A1 to A7. Let us draw this table up. Okay, so we have A1 to A7, and then we're going to start with the dimensions for A1. So we have 109.4, 108.8, 108.2, and then lastly we have 107.5. We're only going to put these dimensions down for the cut section, right? So we have 4 dimensions, and then we're going to find the total. The total gives us 433.9. So we're going to divide that by 4 and get the average. 433.9 divided by 4, and that gives us 108.48. And then we're going to deduct our formation level, right, which is 107.5, and that gives us a total of 0.975. So that is the depth at A1. Right, now moving on to A2, we're going to start with our first dimension there, which is 109.2, 108.6, 107.9, and 107.5. And then we're gonna calculate the total as well, like we did for A1. That gives us 433.2, and then we have 4 levels here, so we're going to divide that by 4 as well. So we get an average of 108.3, and then we're going to subtract 107.5 to get our average depth at A2, 108.3 minus 107.5, that gives us 0.80. And then we're going to move on to A3. We have 108.8. And then we're going to get the total for that. The total is 432.3, and then we're going to divide it by 4 because we have 4 levels there. 108.08, and then we deduct 107.5, and that gives us a depth of 0.57. Moving on to A4, 108.5, 108.2, and then 107.5. We have 3 levels there, so we're going to get the total. The total gives us 324.2, And then because we have 3 levels, we're going to divide that by 3. And then we're going to get the average. Okay, so we get 108.07, right? And then when we subtract 107.5, we get a total of 0.57. Now moving on to A5. $107.5, we get the total. Then we're going to get the average. The average is 107.9, and then when we deduct 107.5, we get a total of 0.40, so that's our depth at A5. Moving on to A6, we have 108, we have 107.6, we have 107.5, and then we get the total. The total gives us 323.1, and then we're going to divide this by 3 because we have 3 levels. Okay, so the average gives us 107.7. So we're going to say 107.7 minus 107.5, and that gives us 0.20. Now moving on to A7, we have 107.7, 107.5, and it's just those 2 levels. We're going to divide it by 2, and then we get a total of 107.6, and then we subtract 107.5, and that gives us 0.10 as the depth for A7. Okay, all right, so we have just worked out all the depths, right? And we know the distance between the cross sections, which is 20 meters. Now the third dimension will be the length of the different sections, right? So A1, for example, has a length of 2, 4, 6, so it's 60 meters, right? So that is the length for A1. Let's put dimensions down for A1. So we're going to start with the 20 meters, which is distance between the section. So it's 20 meters. And then we're going to put that length of 60 meters. And then the last dimension there that we're going to put is our depth of 0.975. Now, as per Simpson's rule, we're going to multiply this by 1/3. Now let's reference that as A1. And then moving on to A2, we have 20 meters. Okay, so now we need to determine the length, right, for A2, because it's not as straightforward as A1. So we know that between 109.2 and 108.6, we have 20 meters. Between 108.6 and 107.9, we have 20 meters. And we know that between 107.9 and 107.2, we have 20 meters. However, there are portions of that 20 meters that fall under our cut quantities, and then the other portion falls under our fill quantities. So in order to determine our X value, we are going to use similar triangles, right? Now remember, we are working to a level of 107.5. So for our cut section, we are going to take 107.9 and subtract 107.5, and that gives us a depth of 0.4 meters. So that 0.4 meters is going to be for our cut section. And then for the fill section, we are going to take 107.5, right, and say unless 107.2, and that gives us 0.3 meters. Now, using similar triangles, we're going to take 20 over 0.7 equal to x over 0.3, which is going to be equal to 6, or 20 multiplied by the 0.3 gives us 6. 0.7 multiplied by x is 0.7x, and then we're gonna say 6 divided by 0.7, and that will give us x is equal to 8.57, but that will be the length for the fill. Cut is equal to 20 plus 20 plus 20 minus 8.57, and that gives us 51.43 as the length for A2. So now we have the 3 dimensions, we can put those down. So we have here 51.43, and then we have our depth of 0.80. Okay, so we're going to multiply it by 1 over 3 times 4 because it's an even numbered section, A2. So let's reference that as A2. Now moving on to A3, which is an odd numbered section. With A3, we have a similar situation. We need to work out the length for the cut section. Okay, so we're going to use similar triangles as well. We have 107.6, right, to 107.5 forming a part of our cut section. And then we have 107.5 or 106.6 to 107.5 forming part of our fill section. So if we say 107.6 minus 107.5, we get 0.1 meters, right? And then when we take 107.5, subtract 106.6, we get a depth of 0.9 meters or a height of 0.9 meters, right? So using similar triangles, 20 over 1 meter equal to x over 0.9. So that gives us 18 equals to 1.0x. And then x will be equal to 18, right? But that will be for the fill portion. Now, in order to get for the cut section, we will say 20 plus 20 plus 20 minus 18, and that gives us 42. So we're going to put down our dimensions there. For A3, we have 20 meters by 42, and then we have worked out our depth there of 0.57. And now, because this is an odd numbered section, we'll have 1 over 3 times 2 times 20 times 42 times 0.57, and then we're going to reference this as A3. Now moving on to A4, we know that dimension already, and because it's an even numbered section, A4, we're going to multiply it by 4 and by 1 over 3, so we're going to put those dimensions down already. Okay, so for A4, we have 108.2 minus 107.5, which gives us 0.7 meters, and then 107.5 minus 107.4 gives us 0.1 meters. So for our large triangle, we will have 20 meters divided by 0.8 meters, and then for the small triangle, we will have x divided by 0.1 meters. And then when we cross multiply, we have 2 is equal to 0.8x, and then our x will be equal to, the 2.5 is for fill, so we need to determine for cut, which is going to be 20 plus 20 minus 2.5, and that gives us 37.50. So we can put that down in our dimension column. So we have that, and then we have our depth for A4, which is 0.57, right? And then we reference that as A4. Okay, now moving on to A5. So for A5, we also need to solve for x. So we're going to take 108 minus 107.5, and that gives us 0.5 meters. And then we have 107.2 or 107.5 minus 107.2, and that gives us 0.3 meters. So we're going to have 20 meters divided by 0.8 meters, which is equal to x over 0.3. And then when we cross multiply, we have 6 equal to 0.8x. So our x will be equal to 6 divided by 0.8, which gives us 7.5 for the fill. And then for the cut, we will have 32.50. So we can go back to our dimension column. We know that distance there. We just worked out this 32.5. And then our depth, which is for A5, is 0.40. Okay, so we're going to reference that as A5. Now moving on to A6. Okay, so we have 107.6 minus 107.5, which gives us 0.1 meters. And then 107.5 minus 107.3, which is 0.2 meters. So for the large triangle, we will have 0.3 meters. And then for the small triangle, we will have 0.2 meters. So we are going to take 20 meters divided by 0.3 meters equals to x divided by 0.2. And then when we cross multiply, we remain with 4 equal to 0.3x. And then x will be equal to 13.33, but that is for the fill. Our cut will be equal to 20 plus 20 minus 13.333, which gives us 26.667. And now we can go back to our dimension column and insert our dimensions So we know that that is 20. And then we have 26.667. And then our depth of 0.20. Because this is an even numbered section, we're going to multiply it by 1/3 and 4. Okay, so we're going to reference that as A6. Okay, now moving on to the last section, which is A7. So for A7, we need to solve for x. We have 107.7 minus 107.5, which gives us 0.2 meters. And then 107.5 minus 107.4, which gives us 0.1 meters. So 20 meters over 0.3 meters, which is equal to x over 0.1. And then when you cross multiply, 2 is equal to 0.3x. Then we solve for x. So x will be equal to 6.666. And then our cut will then be 20 minus 6.66, which gives us 13.334. Then we can move on to our dimension column, right? We know it's 20 meters. Have that. And then our depth. Now, because this is the last section, we only multiply it by 1/3 as per the rule. If you watched till the end, thank you so much for watching. I really hope that you found the tutorial valuable and informative. I'll see you guys in the next one.